then that if non-parallel sides of a trapezium is equal, then it's cyclic, right? So here I am taking one trapezium whose non-parallel sides are equal, right? So this is a trapezium. So this is a trapezium whose non-parallel sides, okay, are equal. In a trapezium, we know that there is a pair of sides which are parallel. So these are the pair of parallel sides, right? Now, if these are the pair of parallel sides, these are the parallel sides. Then what are the non-parallel sides? You can see this one, right? The remaining another pair are non-parallel. So we can say this is non-parallel and this is also non-parallel. Non-parallel means the sides which are not parallel to each other, right? So let us name this trapezium as A, B, C and D, right? Now, if you are marking this trapezium as ABCD, then we can say that AB and CD are parallel to each other. So I am writing over here AB using this symbol, AB parallel to CD, and the non-parallel sides, that means AD is not parallel to CD, AD is not parallel to BC, but AD is equal to BC. This is the condition given into the question. So AD is equal to BC, right? So we need to prove that the trapezium ABCD is a cyclic. You know what is cyclic? A cyclic quadrilateral is that quadrilateral which is having the opposite angle sum as 180 degree. So here in this trapezium we will prove the same, right? So the criteria is that the trapezium ABCD is cyclic. We need to prove this, right? So just to prove this, what we will do? We will do we do a simple construction. Since AB is parallel to CD and AD is equal to BC as it's given, right? So do the construction that draw a parallel line parallel to AD like this. Let us assume it's intersect CD at a point P. So we can say that AD is parallel to BP, right? Since AD is parallel to BP, so we can say that AD and BP are also a pair of parallel sides and AB and DP are already parallel, which I have already written over here, right? So we can say that AB and CD are two parallel lines. So ABPD is a parallelogram. ABPD is a parallelogram. I am using the symbol like this, slanting to slanting lines. So students, I am assuming that you are understanding that this is a symbol of parallelogram, right? So if ABPD is a parallelogram, I mean to say this one, if this is a parallelogram, right, we know that for a parallelogram the interior opposite angles are always equal. I mean to say this angle, let us say this is angle 1, this will be equal to this angle, that is angle 2, right? So we can say that if ABPD is a parallelogram, then angle 1 is equal to angle 2. Angle 1 is equal to angle 2. What it reflects? It reflects that That means angle BAD is equal to angle BPD. So I am just naming this as 1 and 2. If this is equal, we can say this is equal, being a parallelogram. ABPD is a parallelogram, right? Now, coming on to the construction, we have already constructed BP as parallel to AD, and it's given that AD is equal to BC. Here you can just see AD is equal to BC. So if AD equal to BC, and we have shown that ABPD is a parallelogram, then we can say that BP is also equal to BC. We can say that AD is equal to BC is equal to BP, right? One criteria is already given over here into this question, and this third, after doing this construction and after proving ABPD is a parallelogram, we can say that AD equal to BC equal to BP. And students, we know that in any triangle, so we are considering here the triangle BCP. In any triangle, just I am marking with a black pen so that you will be able to understand it, right? So considering this triangle BCP, in triangle BCP, what is the difference over here? You can say in triangle BCP, we can see BP is equal to BC. Since BP is equal to BC, so we can say that this angle BPC is equal to angle BCP. So just writing it very clearly, just mention it as angle 3 and mention angle BCP as angle 4. This one as angle 4, right? So angle 3 will be is equal to angle 4. But what is angle 4, right? So what is angle 3 and what is angle 4? Angle 3 is angle BPC. Angle 3 is angle BPC. And what is angle 4? Angle 4 is angle BCP. Angle BCP. Why? Why these are equal? As I said, the angles opposite to the equal sides of a triangle are always equal, right? So that's why angle 3 is equal to angle 4, and this is angle 3 and this is angle 4, right? Just I am using the nomenclature of angles as 1, 2, 3 and 4, so that you will be it will be easy to understand what is exactly happening, and it's clear to memorize, right? So we can see that these two angles are equal. If these two angles are equal, then we can say that angle 3 is equal to angle 4, and we have already proved angle 1 is equal to angle 2, right? And we also know that angle 3 and angle 2, this will be coming, the sum of these both angles will be coming as 180 degree, right? How you know it? See here, angle 3 is the angle BPC and angle BPD is angle 2, this one, this is angle 2, right? So 2 plus 3 will be 180 degree. If 2 plus 3 is 180 degree and 3 is equal to angle 4, so just put up this value of angle 4, or put this angle 4 in place of angle 3. So we can see, after replacing angle 3 with angle 4 from here, that angle 4 plus angle 2 is equal to 180 degree, and angle 2 is equal to angle 1. Okay, angle 2 is equal to angle 1. So put this value over here. So finally we can say that angle 4 plus angle 1 is equal to 180 degree. That means angle 4 is this angle and angle 1 is this angle. If these two angles sum is equal to 180 degree, we can say that ABCD is a cyclic trapezium or a cyclic quadrilateral, and our quadrilateral over here is cyclic, is trapezium, right? So here we are just proved that ABCD is a cyclic trapezium. So I have put up the source of the same question yesterday, so you can refer that, and I will attach this live section along with that. Okay, so just keep on learning and let me know if any further query or any question on this. I will explain. Okay, so let me see the chat section, because in the meantime I have not seen it. Yes, so this is the I hope the explanation of the question is clear. Okay, if any queries is there, just post me into the chat section. I will try to resolve it. Yeah, Dylan, what's going on? Yep, actually Dylan, I am just explaining a question for which I have put a shorts yesterday. Okay, that how to prove a cyclic quadrilateral being and how to prove a trapezium as a cyclic quadrilateral if its non-parallel sides are equal, right? So I have just explained the same question, because in a shorts in 1 minute it's very difficult to explain all the parts, right? And in a single minute it's very difficult to explain all the things in details and explaining the question. So that's why I just coming up with live section, so that it will be easier to all students to understand, right? Yeah, yeah, new Tahoe Moses, why confused? Let me know. Should I explain it again? So I'm just quickly summarizing it. This is a trapezium which is given, okay, and the non-parallel sides are equal. The non-parallel sides are AD and BC, right? If the non-parallel sides are AD and BC, do a simple construction. Draw BP parallel to AD. If you will draw BP parallel to AD, we can see ABPD is a parallelogram. ABPD is a parallelogram. How? Because the opposite pair of sides are equal and parallel, right? It's given that AD is equal to BP, right? As per our construction. And BP is equal, and BC and AD are equal, being non-parallel sides, right? So we can say that BP is equal to BC, just using the two correlations, this one. So after that we can say that if BP is equal to BC, then in triangle BCP angle 3 is equal to angle 4, right? Why? We know that in a triangle, if the angles opposite to equal sides are equal, then the corresponding sides are equal and angles are equal. So we can say that if in angle BC, in triangle BCP, angle 3 is equal to angle 4, then we can say that BP is equal to BC. And here it's vice versa. We have proved BP is equal to BC, so angle 3 is equal to angle 4, right? So I have written over same over here, right? Angle 3 is equal to angle 4. Now, since we have proved ABPD is a parallelogram, right? So angle 1 will be equal to angle 2. Why angle 1 will be equal to angle 2? Because the opposite angle of a parallelogram is always equal, interior opposite angle, the opposite angles. Here you can say 1 and 2 are equal. And we have proved 3 and 4 are equal. So we have two relations with us, 1 equal to 2 and 3 equal to 4, right? So we use another set of information, that is, you can see CPD is a straight line. Being a straight line, angle 2 and angle 3 sum will be equal to 180 degree. So I have just mentioned it over here. Angle 2 plus angle 3 is equal to 180 degree. Now just replace the value of angle 2 with angle 1 and angle 4 with angle 3 here. So just I have replaced these values over here. It's very simple. So we can say that angle 2 plus 4 equal to 180 or 1 plus 4 equal to 180. If angle 1 and angle 4 sum is equal to 180 degree, we can say that this is a cyclic. This trapezium is cyclic because for any cyclic quadrilateral, the sum of opposite angles is equal. Okay. For any cyclic quadrilateral, though the quadrilateral over here is trapezium, for any cyclic quadrilateral, the sum of opposite angles is 180 degree, right? So we can say that ABCD is a cyclic trapezium, right? I hope you are able to understand it, right? So any query, I think I will be able to respond your queries if there will be someone into the chat, but let me know if I am able to explain you. So thank you so much for watching. Just like and subscribe to my channel and keep on learning. Okay. If something is there, some queries are there, just post me into the chat. I will respond to it on getting time as early as possible. And happy learning. Keep on learning. Bye bye. So I'm closing this session now. So I'm coming up tomorrow morning again with explanation of my previous thoughts and some few another more questions with some applying different tactics. Thank you.